It's Sofox again, and with the Arduino projects book, and now we're doing chapter 04, color mixing lamp. Now this is kind of going to be a bit of an important one because it teaches about pulse width modulation, and that's the case of when you turn on and off a pulse really fast or really slowly. So for instance, if you want a light to go full brightness, you just have it on. If you want it to go off, you have it off. But if you want it to go half brightness, what you do is you turn it on for, say, I don't know the exact time, but turn it on for 5 milliseconds and off for 5 milliseconds and on for 5 milliseconds and off. So it goes back and forth and just keep doing that. It's like flicking it on off so fast that the eye can't see it, but it dims. It's a pretty clever technique that's used a lot, so it's pretty useful. So to start things off, let us destroy and rent all the work we did on the last thing and get on to the next chapter. Remember our temperature sensor? Yeah. So, first up, as you can see here, we basically need there's a new lamp here, and this is going to be a fun part. What you see here is not a simple LED. It is an LED that has got 3 LEDs in it. A red one, a green one, and a blue one. Now you can see it from the spokes, how it's got 3 little spokes on it, and that's the whole point. You can just put different voltages in each of them. Well, not so much different voltages, but different, vibrating pulse width modulations into each of them, and therefore you can control the brightness of red, control the brightness of green, and control the brightness of blue. Now, when you combine those 3 colors together, of course, that gives us RGB, red, green, blue, and you could theoretically pull any color from this that you want. In practical terms, it's not going to be quite like that because, this is a set of electronic stuff, but it's still going to give you a damn good range of color. Now, we're also going to be bringing these. These are photoresistors. So the brighter it is, okay, I honestly forget if it's brighter that they have less resistance, and if it's darker they have more resistance, or if it's darker they have more resistance, darker they're less resistance, and bright it's more resistance. Look, one or the other. I think it's when the light goes up they have less resistance, so electricity flows through it faster. And that way you can actually have bits that are controlled by light. So we're using light to control light. Great, it is almost poetic. So let's move on to our assignment. And so first things first, we've got our positive here, and we take a positive and extend it so that we light this one up, the one on the other side of the whole thing. So danger, high voltage. Okay, next we have, and once again there's 2 main resistors. One are the 220 ohm resistors, and the others are the 10k ohm resistors. And these ones will just go feeding right into the, let's just do it. Okay, so they're using pins 12, and then there's 13 is for this black thing here, and 14 and 15. So let's just keep it relatively the same. 12. There we are, 12. Wait, these the and 14 and 15. Got to make sure that they don't connect with each other. Now we need a cable, preferably a dark cable, to connect the yes, this is the ground, and connect the ground with the pin in between. And by the way, like I said, you don't need to use a dark cable, but I like to keep it I like to pretend there's a consistent pattern to what I'm doing. Well, no, actually that's a lie. Sometimes I like to act completely chaotic. Okay, that's not long enough, even if this was the right color. Okay, it looks like we're breaking convention. We're having a red cable use ground. Are you happy, world? There. That fits, even though it totally breaks convention because you're meant to use. Okay, so now let's put this in, and I've just realized we have to make sure we put in the right pin. So the longest one is negative, which is weird because most of the time isn't it the shortest one that's negative? Anyway, with most LED pins, there's usually a flattened edge showing which is, flattened edge which is showing which is the negative one, but in this case it's the positive one, And there we go. So we get one pin in there, which is of course connected to the negative, even though we're using a red cable. Okay, there we are. Got to make sure that each pin goes into a different slot. There we are. Okay, we're almost there. We've got 3 of them in. I got to make sure okay, not 2 of them in, but there we are. A little more wiggling back and forth. Okay, I think we got something there. So as you can see, yeah, you can see that. Okay, now we need to connect, yeah, each of those is in, negatives connect to the negative. Now we need to connect 12, 14, and 15 to, okay, now this is the important part. Only certain pins can actually do pulse width modulation. I don't know if you can see closely, but you can sort of see a sort of a wavy line before 11, before 10, and before 9, and also before 6 and 5, and also 3. This wavy line means that the pin is capable of pulse width modulation. So I don't exactly know why. So according to this document, it says that okay, there's even wires crossing here, which makes things far more complicated. But essentially, you use 11, 10, and 9 to control those 3 pins. So let's get some small-ish cables that should still do us justice. Okay. So 11, which one does 11 go to? Eleven goes to the middle one. It goes to, okay, so it goes to the middle one for some reason. Just plug it into 14, which should connect it there to the this pin. Now, according to that one, that should be the blue pin. Okay, so 9 is going to be the red one. Wait, 9 is... Okay, I'm confused. Ah, screw it. Look, it really doesn't matter which one you plugs into where, because the worst case scenario, you get the wiring wrong, and then you just change it in software. We're controlling this entirely through software, so if we connect 2 of the wrong one, as long as they're all connected to some things that actually do pulse width modulation, I just have to be ready for it. Yeah, according to this is meant to cross over and go up here. I'll just follow it, but even if I'm wrong... Yeah, there we are. And one more time, we're going to celebrate, yeah. And once again, 15 and into 9. So the circuit is fine. It goes straight from the 1110. Then it goes through the resistors up into the LED. There are 3 paths going into the multicolor LED, and then coming out through the negative through there. That all looks good. So next we need the photoresistors, which we have here. Now I don't believe there's any difference. They're, at the end of the day, they're resistors, so it doesn't matter which way around they are. So the thing suggests we put 1 here and puts 1 like 2 up, which is fine with me. And 2 more up. So the idea is we need to measure the resistance of this as it gets varied. As it varies. So in order to do that, we need, once again, our 10 kilo ohm resistors. So essentially, yes, that's right. First of all, we wire them up directly to the voltage that we set up earlier, if you recall. On our last thing. So let's get this one wired up. Good. Yeah, this one wired up. And this one wired up. Yeah, I think I've almost given up on trying to keep my colors straight on this. So remember how we measure resistors. We basically put a current through them and through another big resistor. Yes, this is brown, black, and yellow, and to ground. But in the middle, we measure these values. So let's go, yes, as you can see, we go from here and go into the negative. Okay, so that's the resistors. Oh, damn it. Yeah, it'll be fine. So voltage comes in here, goes through the photoresistor, and goes through here. So the photoresistor has some resistance, and the resistor here has a set amount of resistance, but this varies. So the idea is if you've got two resistors between each other, then the voltage in them will depend on the value of the resistors on either side. But obviously if the resistance of one of them varies back and forth, then the voltage in the middle will vary. So that's exactly what we're taking advantage of. We are hooking them to A0, A1, and A2, which will read them in terms of analog values. So this one goes here. Oh, right, we still apparently got to unhook them from last time. And also we seem to have an LED still on this board. I'm not sure how I let that happen. Oh wait, no, we still need that. That's the ground, yeah. So yes, this is A0. A1. And they probably took two long wires for this, but anyway, and A2. So that's all the wiring. So let's just remind us, there's two parts. This part which sends voltage of varying levels to different lights on this, and this which reads the light value on these things. Now, the instructions also say these things about these gels. They give us 3 colored gels. And the idea is that we put one over each of them, and therefore if we shine like a green light, then this one will light up, but the other two won't, because this one lets green light go through, but it doesn't let the others. Truthfully, I don't really have any colored light. Look, I'm just skipping that, okay? I am, yes. Okay, on to the next bit. We'll need to go into the cyber code part of this whole thing. So, hope you enjoy. Okay, we're in the code, and we've still got yesterday's experiment, or the other day's experiment. So let's dig in and dive in and get coding. So the first thing we do is we set our pins for what each one is. Const int green LED PIN equals 9, at least I hope it was. Const int red LED PIN equals 11. Const int blue LED PIN equals 10, which I hope it is. And okay, look, I'm going to be honest here. Normally I'd go through the instructions, but I'm going to do what the smart person does and test out the code I have just to make sure it actually works. So let's see now. First of all, we have to set pin. Oh well, I suppose we should set the serial. Dot begin. 9600, that's just to make sure we can print out output, and in mode green AD PIN ATT script shortcut. Okay. So let's set all those 3 pins and their light thing. As you can see through the wonders of modern technology, I've actually got a live preview of the Arduino kit. But the great thing is that it's live, and the other thing is I had to use a web browser to get it, because apparently getting a simple program that just shows you what's on the webcam is actually a surprisingly difficult task. I will not try to go into it myself. So all we have to do is, there we are, we do an analog write. N-A-L-O-G. Okay, that's not how you spell it apparently. T, or at least it's not. No. Red, LED, P-I-N, and red value. And the red value has to be a value. Yes. A value of 127 will set the pin high half the time of the period, making the... Oh yes. A value of 127 will set the pin high half the time, making the LED dimmer. 0 would set the pin to low, turning the LED off. To convert between the sensor reading and the thing design, a value of 0 to 255 for analog write. Okay. So in other words, let's just dive right in. Let's just set it to full brightness just to make sure that we're actually doing this the right way. Oh, right. Yes, this is the color mixing lamp. C-O-L-O-U, or mixing L-A-M-P. Save, compile, and if everything goes red, this should go red. Goes right, this should go red. So for once, you know, red is actually the sign of success rather than potential danger. And it's done uploading, and I don't see it doing anything. Okay. Okay. Let's dig into why. Let's first of all look into it the cheapskate way by just hooking up voltage directly to this. So let's see if this works. No, that does not work. Okay, that does not work either. Okay, what's going on here? Okay, this one is definitely, it's hooked up to negative. This is definitely, okay, are these lights even like, is it even like meant to be working? Okay, look. Is this on? Is this thing on? Is there a short circuit? So, we'll take this thing just as a quick test. We'll put the flat side is negative, right? Yeah. So if we put this here and here, so kind of in series. No, wait, yeah, there. Between there and there. And set this up. Should this go on? No, it does not go on. Okay, okay, that's it. I'm diving it directly in and seeing if this works. Okay, what the heck is going on here? Okay, is this even wired up? Oh, no, it is. This is leading to ground, this yellow wire, so there's ground. Okay, so it's not actually on. Okay then, somehow in my haste to remove all the cables, I seem to have removed the voltage that actually makes the plus and the... Okay, wait, this is it. This is it. This should be in plus. So, SEL, SEN, ST... Where the heck is this? Excuse me for a moment. I need to actually make sure that my circuit is getting power so that it doesn't completely crash. Okay. No, wait, yeah, there's the negative, and that's going to ground. That's all as it should be. And here's the positive. And here it is going to 5 volts. Okay. So now it should work when I do this. Oh, it does. So why is it not doing it regularly? Okay, so it should work when I do this as well. Yeah, there's blue. Oh, I hope this is probably terrible resolution. Sorry, I should switch over. And there's green. So let me just quickly switch this over to the other moment. Yeah, so just to be clear, I was hooked up the power from there to there because that was missing. So, and then I've taken this, plugged it into plus, and tapped it against this that shows red works, that shows blue works, and that shows that green works. Now the only problem is, if this program was already meant to be setting red to high, why is it totally not working? So we've got this, which is, it should be there. We've got this one, which is set to, sorry, wait. This is red, and it's got 12, which is set to 9. And double checking the Arduino source code. Yeah, we set red pin to 9. What numbers did we use? We used 8, 9, and 10. But apparently the pins I've got are 9, 11, and 10. Okay, so... Okay, I shouldn't have hooked... Apparently I'm using 8, 9, and 10 when I should be using 9, 10, and 11. I don't know why I mistook that. That's it. I'm taking this 8, and I'm putting it into 11, and I know that technically... Oh, there we are. So it works now, kind of. The point is, we set this up, but apparently it's for green, not with red. So, all we need to do now is head back to our source code and just change the numbers so that it shows the right color for each one, which is pretty much what we're going to do now. Okay, so by setting red LED pin to 255, we set the green pin. So obviously the green is 11 and the red is, I don't know, 9. Let's try this again. So let's start it up, and yes, the red is 9. So if we set this to blue, we should get a nice blue color. Yes, we do indeed. So let's try to dim the blue color to, let's say, 100. That should be less than half brightness, and see if it dims. Okay, it doesn't look that dimmy. I'll set this to 50. It could just be the light or camera or something. Okay, hang on a sec. I'm gonna actually just look at it when it changes, because apparently maybe the camera's just not picking it up. Yeah, it looks pretty bright, but I don't know. Let's see this. Yeah, okay. So that's really low. And if I set this to 5 instead. Okay, that's brighter. And if I set it to 50, that's pretty bright. And if I set this to 250, okay, yeah. So as you can see, it's varying depending on brightness. So now that I've tested out to make sure that those pins are correct, let's move over to the red sensor, to the sensor pins. Equals E2. And then we got some more things. Int red value equals 0. Int green value equals 0. Int blue value equals 0. Yeah, I'm totally inconsistent with these lines. Int red sensor value equals 0. And yes, I think I can, and more copy pasting. Alright, so now we got that set up, more or less, and we've already got most of the other things set up because I went ahead. It's pretty straightforward. Red sensor value is the analog read of the red sensor pin. So the red sensor pin is A0, and we continue on with this. There's a delay for some reason. Let me just check it out. Put a small delay between the analog read as the ADC takes a millisecond to do its work. Yes. Okay, so, and then we just copy paste once again. Red, green, blue. Feel free to skip some of this boring typing. Not too much of it, because I'm really an awesome person, I swear. But, yeah, I know. So I'm getting a little bummed out. So after you've done the reads, you do serial value. Okay. Serial.print. You're meant to print out raw sensor. Yeah, you're meant to print out something like raw sensor values /t red. Oh dear gosh, this is boring. Okay, red value. Okay, I'll throw in the -t because this is right. This is just a tab. It gets everything nicely formatted. and red. And yeah, okay, red. Yeah, I got the general gist. Okay. Red, green, green, blue. And in a second we'll find out which is which when it comes to when light is shown on these things. Okay, yeah, so this is just that, but let's just skip the mapping right now, because this is just how you convert from one to another. And let's just get this thing, let's just light this thing, let's come this out for now. Let's light this thing up and see what the serial value are. So, serial monitor. Okay, you can give me more than that. Okay. I was one, that's probably, no, that's not good. I mean, it's good-ish. Okay, let's throw a delay here for about 100 milliseconds. And let's try to actually make sure, yeah, I'm pretty sure they misprinted this. They should be it should be red value, and then you tab, and then there should be like a print ln here, and then so that it prints that. Yeah, there, no, there we are. This should be print line, so it goes on to the next. No, I got it. The last one should be print ln. That's it, should right? Yeah. Okay, I misread from the book. Sue me. I'm willing to take back. I'm willing to be liable for all the time. Anyway, okay. Tools, serial monitor. Come on, you can do it. Yeah. Okay. That's good. Except my terrible formatting is at work. Okay. So yeah, okay, that is really terrible. I'm sorry. I'll just print that out. I'll put a dash T before here and a dash T before here. There we are. I mean, you know, as a programmer, it doesn't need to be like completely nice, but you're still gonna make it readable out of all things. You can do it. Okay, that's good. We can roll with this. We can do this. It's cool. So I'm going to put my finger over the one light resistor, this one, and see if any value drops. Okay, the red value. So the top one must be the red value. That's only in the 400s, where the other in the 800s. So that means that the resistance, yeah, it's reading the voltage and the lower voltage. Yes, so light makes the resistance go down. Shouldn't that increase the voltage? One or the other. But the point is, and then I'm putting my finger over the middle one, and that makes the green value go down, whereas the other two are kind of okay, although my finger's kind of... And the last one, yes. I put my finger over the last one, it drives to 500. So with that done, the book suggests now what we do is do a mapping thing. We basically take the values that are read from here and map them in. Now, in order to do that, we need to reduce the value, and that's simply by red value. You see the max of the sensor. When you read the voltage, it'll give a value from 0 to 1023. So in order to get from 0 to 1023 to 0 to 255, you need to divide by 4. Red value equals red sensor value divided by 4. Green value equals green sensor value divided by 4. Blue value equals blue sensor value divided by 4. So then we just simply, yeah, just like we did before, and we do, well, we did just copy this. Red value, green value, blue value, and reduce this with red LED, green. Mapping doesn't really work since I haven't even used the gels, and then blue. So I've still set a delay of 100, but I'm going to keep that in there. The book doesn't seem to have it, but I'm more comfortable with it, so, you know, back to my decision making. So we've started out, and it's blue, I guess. Oh, no, it's purplish. Alright, so what happens if I close all of these except this one? Ooh, it goes nice reddy color. So what happens if I close these two ones? Okay, that's good. I think it's also going a reddy color. Or is it a bluey color? I don't know. And okay, so that's red. Okay, that's it. I am doing this. Okay, that's not working as well as I thought. I'm going to move the light so that it's more direct. And as you can see, it kind of does have the values. Well, am I making a mistake here? Okay, so that's red. This should be the red resistor. So that should be green. Why am I not seeing any green? It just still kind of looks red. Okay, that's blue. That kind of looks blue, bluish. Okay, that's it. What happens if I just take these out entirely? Okay, there's blue. Blue? Why is it blue? There should be green values going on here. There should be at least one green value. If I take this out, is this going to just go black? I mean, go out completely? Oh no, there's the green value. Sheesh, green. You were kind of getting overpowered there, I have to say. Yeah, so basically when I block the light, we get less blue, but there still doesn't seem to be much green to make a difference. I mean, I have to take this resistor out. What is up with green today? And now we'll get that in, so we get red. I've really done the, yeah, green value. Okay, that's red. That's more red. That's even more red. This is less red, even though it's kind of reddy. And it seems that it's really hard to get green to show up. But I let go of this and blue shows up no problem. Okay, this is a very messy kind of thing. Maybe if I throw in some of these gels, see if it makes much of a difference. But I think this will only really make a matter if the lights change. Okay, I probably should have switched back to that. I think this is making me... Okay, so there we have a thing that kind of works, and it's meant to work, but honestly, it's just tricky. It definitely changes. The amount of light you show into these things does actually change the color, but I'm not seeing much of a color difference in this. Theoretically, if I close these two off, I should be getting a green color, but nothing happens. Yeah, if I close these two off, then I am getting a reddy color, and if I clean these two off, yeah, I am kind of getting a more bluey color. So I guess the lesson of this life is that multicolored LEDs are nice, but when you get vague analog values, you probably have to fine-tune them on your own rather than anything. Let's function. So there's a lot of, yeah, they're suggesting use a ping pong ball and like stick it over it, and then you've got your own little lamp. It's not necessarily a bad idea. Certainly a good way of using a diffuser. Alright, there's a lot of little stuff I can do, but just to finish off, I think I'll just leave it at that. So, thank you all for watching. I think next time we've got something more exciting, a mood cue. Oh boy. I've been waiting for this one. This has got servos in it. Hope you enjoyed.